Hello, this is Britt Castle with another example video. In today's video, I'm covering example 3 from section 5-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to identify an extraneous solution. So understand, when we say extraneous here, really that just means extra. So sometimes when we use exponents to get rid of roots or radicals here, sometimes it generates a second set of solutions. Okay, so for example, think about, come on, pen. Think about like a situation, I don't know why this is not writing, where you have like x squared equals 16. Well, if I take the square root to get x alone, I would get the positive or negative 4, right? Because 4 times 4 is 16, and negative 4 times negative 4 is 16. Okay, so when we introduce raising an exponent here, what we're doing is we are introducing that positive negative split there. So we always just want to check ourselves to make sure that we don't wreck ourselves. Alright, so now that we're done laughing, let's go ahead and look at this one. So remember, our rule to get rid of radicals is to always isolate the radical first. Alright, so because the square root here is already alone, I can go ahead and raise both sides of this equation to the second power and get rid of that radical. And so what ends up happening is now I have an equation that has a quadratic term and a linear term. And the only way to solve equations like this is through methods like factoring or completing the square, quadratic formula. And to do those, I need to get all of my terms onto the same side of the equation and have it set equal to 0. So for that purpose, I'm going to go ahead and subtract the 7x and the 8 in order to get everything onto just one side of the equation. So by doing that, I get x squared minus 7x minus 8 is equal to 0. And this is factorable. Okay, so if I set up my double bubble, I know I have an x in each. This minus sign falls down. And then in order to get a negative 8, my signs have to be opposites. So this one's going to be a plus because I already have a minus. And then I ask myself, what multiplies to make 8 that subtracts to make 7? And that is 8 and 1. So I put the bigger number with the sign that fell down. And now what this is doing is this is introducing two possible solutions, where x is 8 here and where x is negative 1 here. Okay, because I used the zero product property and solved. And so now, because we squared, what we need to do is now we need to check ourselves, and we need to check both of these solutions. Alright, I'm going to try to squeeze it down here at the bottom. So first I'm going to start with the 8. So I have 8 is equal to the square root of 7 times 8 plus 8. Well, 7 times 8 is 56, plus 8 is 64, and the square root of 64 is in fact 8. So 8 is definitely a solution. So now let's check with negative 1. Now I could tell you right now just from looking at this on this very first step that it doesn't work, because you can't take a square root and get a negative number. That's a no-no. But I'm going to pretend like I don't know that and just keep trucking with my life, alright? So 7 times negative 1 is negative 7. Negative 7 plus 8 is 1, and the square root of 1 is 1. And you could see there, negative 1 does not equal 1, so this is extraneous. So there's our extra solution that was introduced by squaring both sides here. Kind of cool. Now part B here, part B is a doozy, y'all. So do you guys see how, usually we have just one term outside the square root here. Now we have two terms. What that does is that introduces us to a whole different can of worms. But really, it's kind of the same can of worms. It's like a can within a can of worms. Anyway, so let's look at this. So our radical's already alone, and we know that to get rid of a radical, we have to raise each side of the equation to the second power. And so what that does is that gives me x plus 2 squared equals x plus 2. Well, that's a problem, right? Because the only way to get rid of that square is to take the square root, and we'd be back to our original, back to the original thing. And that kind of is dumb. So when I go to square each side, what I have to do is I actually have to square. Alright, so I'm going to take a little bit of scratch paper to the side, kind of mope a little bit, and I am actually taking this x plus 2 and timesing it by itself. Alright, so I'm going to start with the x. So x times x is x squared, and x times 2 is 2x. Now I'm going with the 2, so 2 times x is 2x, and 2 times 2 is 4. Collect those like terms, because why not? And so that is what I'm going to be putting here on the left-hand side. Now sometimes it's easy, like this one. You could probably do that with mental math. Sometimes it gets a little sticky, and the best advice I have for you is just to kind of grin and bear it, to be honest with you. There's not really any way to make it clean or friendly. Alright, so now I have quadratic terms and I have linear terms. So just like over here, I need to get everything to one side of the equation and either factor, quadratic formula, complete the square, I don't know, something to get that x solved for, okay? So I'm subtracting the x and the 2 to move them over. So 4x minus x is 3x, and 4 minus 2 is 2. And I rejoice because, ooh, that's a funny looking 0. Let's fix that. And I rejoice because that's factorable. So I'm going to go ahead and set up my double bubble. I get an x and an x. First sign falls down, and to get a positive 2, gotta have twinsies. What multiplies to 2? That adds to 3. That's 2 and 1. And so what's nice about that, if I use the zero product property, is I get two answers where x is negative 2 and x is negative 1. And those are the answers I need to check. Don't worry, the check step is fairly quick, right? It just, most people get frustrated at having to do the check step because they're kind of lazy, which I also get. So here, negative 2 plus 2 is 0. And in the radical, that's another 0. And the square root of 0 is 0. So negative 2 is certainly one of our answers. So now with negative 1. So I have negative 1 plus 2 equals the square root of negative 1 plus 2. So negative 1 plus 2 is 1. And the square root of 1 is 1, so negative 1 is also a solution. So notice, just because I can get an extraneous solution doesn't mean I have to get an extraneous solution. That's why you want to check each and every single solution, okay? Because one might work and one might not. And don't think that just because you check and you get one that doesn't, that the other one will. Okay, so make sure that you check everything. And we all know with Savvas, if you get a part of it wrong, if you don't check yourself, you wreck yourself. Oh, shame on me. I did my try-its before I did the actual problem. Good day, y'all. So let's go ahead and let's do this one. So again, we got our radical alone. So I'm going to go ahead and raise both sides to the second power to get rid of it. So on the left, I'm left with 3x minus 2. And on the right, if I go to the side and get a little bit of scratch paper. Okay, I'm going to distribute the x first. So x times x is x squared, and x times negative 4 is negative 4x. Now I'm doing the same thing with negative 4. So negative 4 times x is negative 4x, and negative 4 times negative 4 is a positive 16. Then we collect those like terms, and so that's what goes on the right-hand side of my equation. All right, so again, I have a square and a linear, so I know I'm going to either factor, quadratic formula, complete the square, I don't know, something to solve it, right? So there we go, I'm moving all those terms on over, so I get that nice equation is equal to 0, which is what we're looking for. And so this is actually factorable, which is nice. So I drop down my first sign, and because I have a plus, I know I need matching symbols. And what multiplies to make 18 that adds to make 11? Well, that's 9 and 2. So those are my possible solutions here, is 9 and 2. So now we got to check, right? So first I'm checking with the 9, so I have the square root of 3 times 9 minus 2 is equal to 9 minus 4. So 3 times 9 is 27, minus 2 is 25, 9 minus 4 is 5, and the square root of 25 is 5. So we know that 9 is good. And then we come on over, and now we're going to use our 2. So I could tell you just from looking at this, this won't work. Why? Because 2 minus 4 is negative 2, and you can't take a square root to get a negative number. But I'm going to keep checking myself just because I want to show you guys. So 3 times 2 is 6, minus 2 is 4, and the square root of 4 is a positive 2. And 2 doesn't equal negative 2, so that is extraneous. All right, now part B here, it says that, well, x equals 2 is extraneous. Haha, I knew it. And they're wondering why that solution arises. So again, remember, let me use my text here. You get extraneous solutions by raising an equation to an exponent. So there we have it, y'all. That is how you identify an extraneous solution and how to solve radical equations that have variables outside of the radical. So until next time.